Welcome to Demystifying Math. In this lesson, we're going to be finding equations for conics in polar form. Let's start with a parabola. This is the general equation for a parabola that has a vertex at the origin and is symmetric to the vertical axis. We're going to convert it to polar form by letting x equal r cosine theta and y equal r sine theta. Next, we're going to isolate r, so we're going to bring the r squared cosine squared theta over to the other side. Then we're going to factor out the r and set each factor equal to 0. In the second equation, I'm going to isolate r, so I brought the r cosine squared theta over to the other side, and then I'm going to divide by cosine squared theta. Now looking at the second equation, r equals 4a sine theta over cosine squared theta, it's equal to 0 whenever the sine of theta is 0, such as that 0, pi, or 2 pi. So since we have r equals 0 in the second equation, we don't need the first equation, so we'll eliminate the r equals 0. So the general equation for a parabola in polar form is r equals 4a sine theta over cosine squared theta, where a is the distance from the vertex to the focus, and this is for a graph that is symmetric to the vertical axis of the line theta equal pi over 2. Let's look at an example. We have r equals 8 sine theta over cosine squared theta. Again, this is a parabola with the vertex at the origin and symmetric to the line theta equal pi over 2. And what I did was I plugged in a few angles. So at 0 we get 0, at pi over 6 we get 16/3, and at pi over 4 we get 8 squareds of 2. On the other side of the line theta equal pi over 2, we have symmetrical points. At 5 pi over 6 we have 16/3, and at 3 pi over 4 we have 8 squareds of 2. Now remember that a is equal to the distance from the vertex to the focus. So a is 2, which means that our focus is at 2 and pi over 2. The directrix is the same distance from the vertex as the focus is, so it's 2 units in the opposite direction. So the directrix is at y equals -2, or in polar form, r sine theta equals -2, or isolating r, you would have -2 over sine theta. Remember that the graph always wraps around the focus and moves away from the directrix. Let's look at a parabola that has a vertex at the origin and is symmetric to the polar axis. So that would be y squared equals 4ax. Again, we're going to convert this to polar form by letting x equal r cosine theta and y equal r sine theta. And we're going to go through the same steps we did before by isolating r. So we get r equals 0, r equals 4a cosine theta over sine squared theta. Again, the second equation will equal 0 wherever the cosine of theta is 0, such as pi over 2 or 3 pi over 2. So we can eliminate the r equals 0 equation, and we simplify to r equals 4a cosine theta over sine squared theta. Again, a is the distance from the vertex to the focus, but this graph is symmetric to the polar axis. Looking at an example for this one, we have r equals 8 cosine theta over sine squared theta. So this one will open to the right and have a vertex at the origin, and I plugged in pi over 3 and negative pi over 3 and got 16/3. The focus again is 2 units away from the vertex, so this one will land at 2, 0. The focus will be on the axis of symmetry for these. And the directrix is 2 units in the opposite direction, so we have r cosine theta equals -2, or x equals -2 in rectangular form. Or if you simplify r, you get, or isolate r, you get -2 over cosine theta. Next, we're going to look at an ellipse, and this one is centered at the origin. So we have x squared over a squared plus y squared over b squared equals 1. So the first thing that we're going to do is clear the fractions. So we're multiplying everything by a squared b squared. Then we're going to convert to polar form by replacing x with r cosine theta and y with r sine theta. Then we're going to isolate r, so I factored out the r squared. And I got r squared times b squared cosine squared theta plus a squared sine squared theta. Then isolating r, we get r squared is a squared b squared over b squared cosine squared theta plus a squared sine squared theta. Then I took the square root of both sides, and I got r equals ab over the square root of b squared cosine squared theta plus a squared sine squared theta. I didn't put the plus or minus because the angle measures you put in will just repeat, so you only need the positive square root. So we have the equation of ellipse centered at the pole. The horizontal axis will have a length of twice a, and the vertical axis will have a length of twice b. Let's let a equal 3 and b equal 2. So we get the equation 6 over the square root of 4 cosine squared theta plus 9 sine squared theta. And I just plugged in a few points to see where the ellipse is. So we have points at 3, 0, and 3 pi, at 2 and pi over 2, and 2 and 3 pi over 2. Now your foci can be found by using the equation a squared minus b squared equals c squared. And we're just going to plug in our a and b, and we get plus or minus square roots of 5. So our foci are at square root of 5, 0, and square root of 5 pi. We can get a stretch or shrink of the graph by multiplying the numerator by a scalar. So this is the same equation we had before, but I multiplied the numerator by 6. So we now have 36 over the square root of 4 cosine squared theta plus 9 sine squared theta. And what this does is magnifies in both directions, horizontally and vertically, by 6. So instead of having our polar points at 3, 0, and 3 pi, we have it at 18, 0, and 18 pi. And for our x-coordinates, they were at 2, so they're now at 12. And we can find our foci in the same way we did last time. So they end up at plus or minus 6 square roots of 5 on the 0 line and on the pi line. All right, let's look at a hyperbola centered at the origin with a horizontal transverse axis. So again, we're going to clear all our fractions and then replace x with r cosine theta and y with r sine theta. And then we're going to factor out our r squared, trying to isolate r, and then divide and square root. So we end up with a similar equation, we just have the minus sign there to indicate that it's a hyperbola. So the vertices will be at a0 and a pi. And this is a hyperbola centered at the origin, and it has a transverse axis along the y-axis. So we're going to go through the same process we did before. All we've done is just exchange x and y. So it'll open up and down. So in this case, you're going to have your vertices at a pi over 2 and a 3 pi over 2. So here's an example of the last one. We have a is 3 and b is 2. So I plugged in a couple points. You can see where your vertices are and make sure they fit your equation. And then you can find your foci. For our hyperbola, it's a squared plus b squared equals c squared. So you get plus or minus square root of 13. So we only need to use the positive, but we could use negative if we wanted to. But one's at square root of 13 and pi over 2, and square root of 13 and 3 pi over 2. All right, thank you for watching Demystifying Math.